wonderful student. How are you today? I bid you a warm welcome to this lesson. In this lesson, we will conclude circle geometry and we will talk about two very important theorems. Now, the first theorem has to do with a quadrilateral inscribed in a circle, and the second has to do with a triangle inscribed in a circle. Now we have plain figures inscribed in a circle for our theorems today. How do we use these theorems? What rules do they follow? How do we use them to solve questions in mathematics? Why not join me in this roller coaster ride as we decipher these questions in this lesson? Let's get this done. The first theorem we'll talk about today is that of the cyclic quadrilateral. Right here we have a quadrilateral ABCD inscribed in a circle. A quadrilateral which is circumscribed in a circle is called a cyclic quadrilateral. In other words, this simply means that all four vertices of the quadrilateral lie on the circumference of the circle. Now there are rules or there are theorems that follows with the cyclic quadrilateral. The first one we have here is that opposite angles of a cyclic quadrilateral are supplementary, or better still, they add up to 180 degrees. It follows from the first diagram that angle A plus angle C will equal to 180 degrees. And sometimes when a line is drawn or extended in the quadrilateral to create an external angle, the rule says that the external angle in the cyclic quadrilateral is equal to the opposite interior angle of the cyclic quadrilateral. Now these are the two major rules right here. The other theorem we'll be talking about in this lesson is that of the alternate segment. Now, in the presence of a tangent, we can have a triangle inscribed in a circle such that all the vertices of the triangle touches the circumference of the circle, and one of the vertices coincide with the point of tangency. Then we can say that the alternate segment states that in any circle, the angle between a chord and the tangent through one of the endpoints of the chord is equal to the angle in the alternate segment. Now, in the alternate segment theorem, there are two angles that are always equal, regardless of the configuration of the triangle, provided each of the vertices lie on the circumference of the triangle and one of the vertices coincide with the point of tangency. We have two angles always equal in the alternate segment. Using our theorems for today to answer questions, our first question for today says, find the value of x in the given diagram. And from what we have here, the line ED is a tangent to the circle ABC, where we have a triangle inscribed. Here we know the angle DAB is the same with the angle ACB because they are angles formed in the alternate segment and they are equal. Now all I have to do is to use the sum of angles in a triangle equals 180 degrees. In other words, I simply say 40 degrees plus 65 degrees plus x will give me 180 degrees. Ultimately, I should have the value of x as 75 degrees. Our second question for today simply says, find the value of x and y. From the diagram, we believe that PQRS is a cyclic quadrilateral because all its vertices lie on the circumference of the circle. In that case, we can say opposite angles of the cyclic quadrilateral are supplementary. So 3x plus x should give us 180 degrees. Solving that further, 4x equals to 180 degrees. X will give us 180 divided by 4. That means our value of x is 45 degrees. And moving to the other pair of supplementary angles, we have it that 5y plus y equals to 180 degrees. And the reason being that opposite angles of a cyclic quadrilateral are supplementary or add up to 180 degrees. In that case, 6y should give us 180 degrees. With proper solving, y should be 30 degrees. Our question 3 simply says, find the value of x plus y in the diagram below. Now, we believe the triangle ABC touches the tangent of the circle at point C. So, because all the vertices of the triangle lie on the circumference of the circle, it means we can use the alternate segment. In other words, angle y is equal to angle x. And using this, we already know that angle y is complementary to the angle at 30 degrees. This is simply because they are the two other angles in a right angle triangle. Now, if our y equals to 60 degrees, it means that x is also equals to 60 degrees. So, you can simply say that angles x plus angle y is 60 degrees plus 60 degrees. Of course, that gives 120 degrees. In question 4, we are required to find the value of n in the given diagram. Now, we know that PQRS is a cyclic quadrilateral. It means that the angle at P should be supplementary to the angle at R, simply because opposite angles of a cyclic quadrilateral are supplementary. So, we have it that 73 plus QRS equals to 180 degrees. At the end of the day, subtract 73 from 180 degrees, we have it as QRS equals to 107 degrees. Now, by using the values of sum of angles in a triangle equals to 180, we can simply find the angle PSQ in the triangle QPF by simply subtracting 73 degrees and 55 degrees from 180 degrees. In that case, our angle PSQ should be 52 degrees and angle QSR should be 30 degrees. And with this, we can simply use the same sum of angles in a triangle to find our angle N. And it should be 107 plus 30 degrees being subtracted from the angle 180 degrees. At the end of the day, our value of N should be 43 degrees.
Wasn't that amazing? And that was circle geometry from the beginning to the end. The two major theorems we talked about today were the cyclic quadrilateral and the alternate segment. The cyclic quadrilateral and the alternate segment. In our next lesson, we'll be treating something entirely different from circle geometry. Till I get to see you again, be a good student. See you. Bye.